Good morning, good afternoon, and good evening, guys, based on the time zones you all are coming from. So, guys, before we start with the session, can you all please give me a quick confirmation if you all can see my screen and hear me loud and clear as well? Perfect. Thank you so much for the confirmation, everyone. So, my name is Neeraj Kedia, and I've been working in this IT industry for more than 13 years now. Let's get started. So main agenda for today's session, we are going to discuss on what exactly is an algorithm, do we mean by machine learning, how a problem is solved using ML, the types of machine learning available, and then we are going to discuss on multiple machine learning algorithms. And then we are going to have a small hands-on if the time allows, and we are going to make use of ML Studio for having a quick hands-on on the subject. So let's get started. So first of all, let's understand what exactly an algorithm is. So in simple layman terms, it's simply a sequence or predefined sequence of steps that is used to complete a given task in simple layman language. For example, we have to, now this is what you may have studied back in 6th or 7th grade. So let's say if you want to make a tea, then making a tea is a complete sequential steps defined in a logic. That means we have to first of all take water in a pan, and then the next step is we have to boil that water. First step is take a water in the pan, then we have to boil that water, and then if the water, then we have a condition. If the water starts boiling, if the condition is defined as yes, then we have to add the tea leaves. If no, then still we have to wait for the water to boil down, and then only we can add the tea leaves. And then if the tea leaf starts boiling again, then we can add sugar and so on. So basically here we have a complete series of steps, and we do have multiple conditions as well. That means if one condition has been fulfilled, then which steps should be taken up? If the step is not fulfilled, then which step should be taken up? As a complete sequence of steps that has to be performed in the given sequence to complete a given task. And that exactly is what algorithm is. So we define how any particular task is going to be completed to the system. And to tell a computer what it must do, we do need a program, and a program is nothing but a logical sequential steps defined in a given language. And we can use any language. For example, here we have logic. So this logic is what an algorithm is, and we can use any language to create that particular logic. So that exactly is what we discussed, a process or set of rules to be followed in calculation in a given sequence. For example, let's say if you want to print a number from 1 to 20, then first of all, we have to initialize x, which is going to be equals to 0. Then we have to increment x by 1. Then we have to print x. Now, if the x value is less than 20, then again it is going to increment it by 1. Then it is going to print x. This is going to keep going on and on until unless x becomes equals to or greater than 20. And then if it is not less than 20, then the entire program is going to end as a complete given sequence. That what we do as a part of the algorithm. All right. So that exactly is what a complete algorithm is. All right. So next we are going to discuss on what exactly machine learning is. So machine learning is a type of artificial intelligence that provides computers with the ability to learn without being explicitly programmed. Machine learning focuses on development of a computer program that can change when exposed to new data. A simple example, let's say we are building a system where we want that particular application should be able to detect if there is any flower in the given image. If there is any flower in the given image, that should be detected. So we have written an algorithm, but again, without training the system, without training the system by showcasing some kind of images, okay, this is what a flower looks like, these are different variations of flower. Without training the system by using multiple flower images, can a system start detecting the flowers in the given images? Without training the system, without any data, so can it detect the flowers on its own? If we have not feeded any flower images to the system, it won't, correct? Same way, the way we talk, the way we understand alphabets, the way we calculate, someone must have trained us, correct? Because we cannot learn these things on our own. Children, they cannot learn these things on their own. Someone must be there to train them, right? So the way we speak, the way we read things, the way our entire brain works. So again, the way we are able to walk, to able to drive, or to anything, we need to get trained first, right? And we get trained by someone giving us input in the format of voice or showcasing some images or we can say showing us some videos as well. So there has to be some input. Then only any human being learns on how things have to be done. Same thing is also applicable to systems as well. If we want anything to be automated, we have to design the algorithm. Obviously, algorithm needs to be there, how things have to be processed. But along with algorithm, the data should also be there to train the system on how things are there, right? And that's why these both complement each other. Without data, without machine learning, automation cannot happen. And that too at a we can say at a higher accuracy level. So this exactly is what machine learning is all about. Now, there are multiple types of machine learning available. We have supervised, then we have unsupervised, and then we have reinforcement learning. So supervised learning method is basically when we are training any system by using a complete guided step, or let's say we have a label data, then we are going to train the system by using that data set, then that is what supervised learning method is all about. So let's say if we talk about supervised learning, then a simple example is email addresses. The most simple example is email addresses. Now, when we receive emails, we now almost a decade back, this was not applied. But nowadays, whenever we are, let's say if you're using Gmail service, right? Let's say if we go back to our annotation mode, let's say we open up our notepad. Just a moment. All right. So let's say if we go back a decade, then at that point of time, all the emails were landed in a single inbox, right? There was a single inbox, and all the email landed in that particular inbox itself, in our primary inbox. But now there has been multiple segregation. Now we have a separate inbox for promotional email. We have separate inbox for the social email as well. We have separate inbox for primary. We have separate inbox for our primary email, and then we have separate inbox for our secondary email as well. Or we can say for our spam folder as well. So now the emails, we don't have to define, okay, which email is going to be put under social, promo, primary, or spam. These things are automatically handled by Gmail itself. Now, this is a simple example for supervised learning method. Now, supervised learning method works on labeled data set. Now, what actually segregates an email, or what should be the criteria for any email that should land the email into promotion inbox? You can try what should be the parameters that should be governing, okay, if this email belongs to the promotional emails. So see, in a promotional email, there are multiple pointers, there are multiple structures. For example, let's say when we talk about any promotional email, then there are multiple pointers for that. The email should not if the email contains multiple images, then again, if the email contains more than 3 images, then that's a recipe of being a promotional email. Three images not as attachments, but again, 3 images embedded in the email itself, then that is a recipe for promotional email. If we have multiple words, like we have offers, buy, discounts, or subscribe, again, these are also a recipe for categorizing any email as a promotional email. If the email contains the options for unsubscribe from the mailing list, then that is also a recipe for the promotional emails. So again, these all pointers are used to automatically identify if this email belongs to a primary or social or secondary or even spam folder. Right, so again, these are all pointers that simply now, if these pointers are available, now these are what? These are the labeled data set. These are the actual text component. These are what? These are the actual labeled data sets. And using these, we can easily segregate them on the, or I can say for the promotional inbox. Same way, any emails coming from the social media platforms, that is Facebook, Twitter, Reddit, Quora, Instagram, Snapchat, Twitter. So again, any emails coming from any of these social media networks, again, they are going to be automatically sorted under the social emails. Same way, any email content like being received from the known contacts, any email containing important keywords like we have invoice, interviews, or let's suppose any meetings or any notices or any email sent to our personal email address from the known contacts, they are a recipe of being listed under the primary inbox. And same way, when we have spam links available, we have links to the website which are having a high spam score, and that's a recipe for the spam email. So these all of are again sorted all together on their own, and this is a simple example for supervised learning, because here we are making use of multiple labeled data set, and that exactly is a simple example for supervised learning. We are using labeled data set for training the system here, then that's what is named as supervised machine learning. So let's erase this up and let's move forward. Next, we have unsupervised learning. Now, unsupervised is what? By using the self-learning module, mostly when we are using unlabeled data set. Now, to understand unsupervised and simple layman terms, we can take the example for any streaming devices. So let's say if we take a small example, we have YouTube, we have Netflix. Now, let's say if we take the example for Netflix. Now, first of all, unsupervised learning means using the unlabeled data set. That exactly is what we have unsupervised learning model defined here. Like learning by using the unlabeled data set. For example, we have YouTube, we have Netflix. Now, let's take a small example. In Netflix, let's say a user has been browsing for different shows. Now, the user has opened up 3 shows. For example, the user tried to watch 3 movies in which genre? In comedy. Suppose the user opened up 3 movies in genre as comedy. Now, the first movie, the movie A, the user watched for, let's say, she watched this movie, let's say, only for 30 seconds. Only for 30 seconds. The movie B, was watched only for, let's say, 1 minute and 45 seconds. 1 minute and 45 seconds. And the third movie C, was watched only for, let's say, 48 seconds. 48 seconds. Now, these are 3 different movies watched under the comedy genre. And now the same user watched another movie, suppose let's say in horror or thriller genre. So again, let's say in horror, the user watched this movie, suppose let's say name as M movie. And now this M movie, the user watched for, let's say, 1 hour and 45 minutes. 1 hour and 45 minutes. 1 hour and 45 minutes. So now Netflix is going to recommend which genre more. Netflix is going to recommend more of comedy movies or more of horror movies. Based on this user statistics, which genre is going to be promoted? Because why? Because here in comedy, we may have watched 3 movies, but again, the movies were not watched actually, right? They were watched only for a couple of minutes. But again, this movie, the single movie was watched for the complete duration. And that will result in making sure that, okay, the user is actually interested in this movie. And that is going to be the basis of recommendation by Netflix. Same way for YouTube as well. Right, so for suppose if we may have been watching, let's say, hundreds of videos, like if we have been watching one specific video type for longer duration, then that's how the entire recommendation system gets rearranged and re-engineered by YouTube and for multiple streaming services as us now. And now here we don't have any kind of labels, right? We don't have any kind of labels. Now, even in horror movies, let's say even in horror, let's say we have watched for multiple actors. Suppose say for other 2 actors we have opened up the movie, but now we haven't watched the movie for those 2 actors. Suppose if this is from actor, let's say this is from actor X and these 2 are from actor Y. So again, if these 2 movies were watched only for, let's say, only for 5 minutes, and this was watched only for 8 minutes, and this was watched for 1 hour 45 minutes. Then even in horror, more movies of this actor is going to be promoted than the others as a part of unlabeled data set. And that is what unsupervised learning is all about. All right, so let's erase this up and let's move forward. Then afterwards, we have something as reinforcement learning. Reinforcement learning is training by example. Reinforcement learning, as the name suggests, it's simply training by example. Reinforcement learning, again, let's say if we can talk about reinforcement learning, and it can be simple in terms, a simple hit and trial method of learning. So we simply award the machine a reward. We simply give the machine a reward or penalty point for each action it performs. If the option is correct, the machine gains the reward point or gets a penalty point in case of a wrong response. So the reinforcement learning algorithm is all about interaction between the environment and the learning agent. Now, to understand this in simple layman terms, just the way we have seen for the first two ML types, let's understand them by simple example. A simple example is, let's say we have a dog. We have a dog, and now we are going to train that particular dog. We do have a specific diagram for parallel dog available. Let's see if we do have that diagram, so we can use it as a reference. So using the diagram, it is going to be much clear for you all. Now, we are looking at if we can fetch the diagram so we can have a better understanding of how things work with the reinforcement learning. All right, so we have a simple example. So here we have taken a simple example for reinforcement learning. Now, any dog's natural, every dog's natural behavior is they salivate even whenever they see a food. Now, this is a natural behavior of every mammal, including humans. So let's suppose if we talk about any human, anyone, again, we start salivating when we see a food of our own choice, correct? That's a natural stimulus, that's a natural response every mammal has, including humans. So this dog is bound to salivate as soon as the dog starts seeing its food, correct? That's the normal behavior. And now let's say we want to train the dog. That means now we are going to train a dog. That means whenever a dog sees, whenever we ring a bell, the dog should start salivating. Now, dogs' natural behavior is not to salivate on hearing a bell because that's not how they are built, correct? But now let's say for a week, we started to ring a bell before we brought the food, right? So normally the dog is not going to salivate until unless the dog sees the food, right? But for a week, we continuously rang a bell before we brought the food to the dog. So after 1 week, what will happen? As soon as we ring a bell, the dog will start salivating just by hearing the bell, because now the dog is going to expect the food to arrive after the dog hears the bell as a part of the reinforcement learning. And how exactly we are training the system? By giving a small response. All right. And that exactly is what reinforcement learning is all about, where we train the system by giving a feedback so that we can modify the entire response accordingly. It's simple Pavlov example to understand reinforcement. And all these self-driven cars, again, car system, again, it has to be continuously evaluated based on the parameters that is currently being entered and all the actions performed by that self-driven car as a part of response of self-learning module, or we can say reinforcement learning modules. So these three are the main types of machine learning that we have. So now if we talk about problem solving using ML, let's talk about problem solving using ML. So problem solving using ML, again, here we have multiple algorithms that we make use of as a part of these three main machine learning model types that we had discussed. So we take a top-down approach to answer the same. These are 5 questions which can be answered in data science. Is this A or B? Is this weird? How much or how many? How this is organized? and what should I do next? So if this is A or B, then this is a simple example for classification algorithm. Now, classification and regression, they are part of supervised learning. Let me highlight that. Classification, this classification, and so the classification is example for supervised, so as regression as well. These are examples for the supervised learning, right? Whereas the clustering algorithm, this is example for the unsupervised learning that we have. Now, if we talk about classification algorithm, now in this type, the output is going to be a categorical value, classifying emails into classes, spam and non-spam, social. Again, this is all a problem of classification algorithm. So for the email sorting, we use classification problem that can be solved by using supervised learning classification algorithm, where we can use support vector machines, where we have naive Bayes, logistic regression, K nearest neighbor, that we have KNN. So these all are examples for classification algorithm that we have structured here. So these are examples for the classification algorithm that we have structured. So let's talk about these algorithms in detail. So we can erase this up. Now, let's talk about the machine learning algorithms. So first of all, we do have classification. So classification, as we discussed, it's used to classify a record. For example, is it cold? Yes or no? Or will you go to work today? Yes or no? Whether this email is promotional or primary, promotional primary. So basically, when we have only two choices, then it is called as two-class classification. If we have more than two choices, it is going to be a multi-class classification algorithm defined. All right. For example, let's say we are going to analyze a certain pattern and alert whenever there is a change in the pattern. So let's say we have the given images, and now out of this given image, we have to find the odd one out. So this one is going to be a complete anomaly. And in real life, your credit card company uses these anomaly detection algorithms and flag any transaction which is not usual as a part of the transaction history. Let's say we have been purchasing mostly from our own country. We don't have any kind of cross-country transactions, right? So again, in case some transaction has happened from some other country, that is going to trigger the alarm. Let's say even in our own country, we have been conducting transactions only from our own city. We don't have any transactions from any other city, even the country itself, then that is going to trigger the you can say abnormal behavior. Let's say we have been taking out cash only from our nearby ATM, and if that there's a cash transaction of and that of a heavy amount from some other ATM, then that is a part of the anomaly. So these all are being used by the credit card companies to find these kind of abnormal behaviors. All right, and there are multiple libraries here where you have the vector machines, we have the naive Bayes, we have logistic regression, we have the KNN, we have the time trees. So it all depends upon the use case. Next, we have regression algorithms. So regression algorithms are used to calculate the numeric values. For example, what will be the temperature tomorrow? Again, that is going to be calculated based on the previous data set and based on the recommendations, how much discount we can give on a particular item. That is also a part of the regression algorithm. So basically, in this type of problem, the output is a continuous quantity. For this example, let's say if we want to predict the speed of a car given the distance, it is a regression problem. Regression problems can be solved by the supervised learning algorithms like we have linear regression. And then we have clustering algorithm. Then we have clustering. Now, clustering is not a part of supervised. Clustering is a part of unsupervised learning. So it helps us in understanding the structure of a data set. So these algorithms separates the data into groups or clusters to ease out the interpretation of the given data. So let's say here we have group A, group B, and group C defined. So by understanding how data is organized, we can better predict the behavior of a particular event. So for example, now we know that again, this type of problem involves assigning the input into two or more clusters based on the feature similarity. So for example, let's say clustering viewers into smaller groups based on their interest, age, geography, etc., which can be used to improvise the ad tech. Now, ad tech solutions, like we have multiple ad platforms, like we have Google Ads, we have social media ad accounts, like we have for Facebook, for Instagram, for Twitter. They have to continuously evaluate which ad is performing well for what type of user base, in which demographic, based on the interest, the behavior. Again, these all things are being calculated. These all things are being derived by using the clustering algorithm for finding these kind of behaviors. All right. So these type of problem involves assigning the input into two or more clusters based on feature similarity. For example, clustering, as we discussed, again, we can make use of the algorithms like we had a k-means clustering. We can use it for sorting the user behavior based on demographics and other parameters. That is what we can define here. Next, we have reinforcement algorithms. So these algorithms were designed as to how the brains of humans or rats respond to punishment or rewards. Like just like we have taken the example for Pavlov. So these are good for systems which must make a lot of decisions without any human guidance applicable. Let's say when any system is going to, when we are going to play a chess, whenever we are making a self-driven car structure, when a temperature control system, when it has to decide whether temperature should be increased or decreased as well. We have multiple tools also available. Like we can, if we are won't have the access to data set locally, then we can make use of Jupyter, or in case you have some kind of data set already available in the cloud, then we can make use of Colab as well. All right, a simple example is, suppose let's say we are working on the analysis on the COVID as well. For example, let's say we open up Colab. Let's say we have this data set with us where let's say we are performing the analysis on COVID-19, then we can open up the Colab notebook file, and in here we can get the data from a given source. So currently, let's say we are performing the analysis for situation of COVID-19 in India, and we can get the API. Then we are here, we are going to make use of the COVID-19 API, which has been made available by covid19india.org. So we can get the access to the API from here. And then for getting started, we can first of all work on getting the entire web context by using the currently now here we are going to work on Python as a main driving force. And before we can work with Python, in case we have the data set already uploaded in a drive, then we are going to import that data by using from google.colab. We are going to import drive, and then we can save the location, and then we can mount our drive so that whatever analysis we are going to do here, that can be saved in that particular drive as well. We can do that. And then we have the Axona. Here we are going to import multiple libraries. Let's say we can import requests for getting the web request. We are going to use JSON library to parse JSON content. Then we are going to parse CSV file by importing CSV. For numerical operations, we are going to import NumPy as NP. Then for storing and analysis, for analyzing data set in data frames, we are going to make use of pandas as PD. And then here we have all the data set which has already been uploaded, or that we are currently importing from the entire web domain as well. So here we are going to make use of pandas library as PD, and here we are going to read the CSV file. So these all are the 12 APIs, 12 CSV file that we are going to import and read. And then we are going to store it as a part of data frame. Now we are going to concatenate all the data frames into a single data frame by the name of full data, where we are going to make use of pandas library, and then we are going to use the concatenate function, where we are going to concatenate all the data set into a single data frame, as in full data. And then we are going to export this full data to the CSV file. So for example, let's say if we want to scrap the today's data. So first of all, we can mount the drive here. For mounting the drive, as you can see, the drive has already been mounted. So now we can work on importing these libraries as well. Let's verify that, okay, this is the domain that we want to use. We can scroll down, click on allow. We have got the authorization code. Now we can copy this. Now this authorization code is going to be presented here so that we can mount our drive successfully if case we are doing that for the first time. once we have entered the authorization code. So this is going to link the Google Drive associated with our Google account that we have authorized here. All right. Perfect. And then we are going to read this data. Now, this data is already available from the API made available by COVID-19. So these all data formats are going to be read, and then these are going to be concatenated. And here we are going to save this in this location. So under my Google Drive, we have a folder by the name of COVID-19. And then under COVID-19, we are going to save data as patients data 1, or let's suppose if you want to rename this, let's say patients data for, let's say 10th of October, right? So here we can define 10th of October 2020. We can save this under this name, and if we rerun the entire file and the entire API, all the API files, they are going to be concatenated into a single data frame, and then this is going to be exported and saved in a Google Drive as under the file name as patients data for 8th of October 2020.csv. So let me showcase you how data is being stored here. So we can go back to our drive, just a moment. So as you can see here, this is the entire data set that has been currently, and this is a patient's data which has been currently exported just now, but the name that we have defined in our Colab notebook file, correct? Which has been saved under COVID-19, and then the patient record has been saved by fetching the data from the given APIs that we had defined here. And this data set contains a patient's record which has been made available in the website altogether. So we can, let's say, to see what exactly is the content here, we can download this. So this is going to be a bit heavy file here because it contains the data set starting from the beginning. That means from 30th of January when the first case was recorded. That means what has been the official statistics. So this is how we can fetch the data set. And again, to view the current data set, we can see this is a current data set that has currently been recorded as a part of having 2.4, almost 247,000 rows of data being added there. And to get the data for daily cases, when here we are going to read the file from the case times keys as CSV, and then we are going to save it as a part of content, and the content we can save daily data set as per the requirement. Same way we can segregate them based on state-wise daily data set, on district-wise, and then we are going to perform multiple analysis as a part of the requirement. Index false means we are not going to create any index for the CSV file that we are going to export here. That's why we had defined the index value to be false. All right. And then here we can work with, now when we are working on the entire analysis, first of all, we have to work on data pre-processing. For example, let's say here we want to remove, we want to replace, or we want to rename certain characters, we can do that. We have to ingest some other data set as a part of feature engineering, then we can also do that. We can also define multiple other pointers. As in we want to rename the columns before we can work on any data set, then we can also do that. So basically here, multiple data pointers are going to be present in this data set, and then we have to make sure that we work on these components one by one. Thank you so much and have a great day ahead. Take care. Bye-bye.